Hello everyone. So this is the second part where we are working on building placement logic. So here, now this is what we are going to do. Here we are going to actually check the validity of the location that we are going to place. So here, if I move my cursor here, this is a place where I can't place the building, so it becomes red. And here I can place, there is enough space, so it is shown in the natural color of the building. But here I can't, so it becomes red. So in a valid place, if I click in an invalid place, so you see the building vanished because I can't place it here. But if I press B again and start go into the building place mode, here if I click, now you see building stays there. So just like this, I can place buildings as I need. So this is just a test function right now. Later on we will associate with this character. So when I select a villager, there we will have a list of buildings that we can place, and when I click that, we will get the building place mode. But right now it's just handled with the key D, because I first want to figure out the building placement logic. Right, so before we started with the tutorial, let me remind you that you can download the project files of this project and all other thousands of projects I have done from my Patreon page. Once you become a member, you can download anything without any limits. To the date, there are over 2000 videos. For each video, project files are here. And here is the full playlist where I have shared everything, so you can follow this and implement everything from scratch. So feel free to check it out. And also this is here I'm using C++, but if you want to follow learn and implement a strategy game with blueprints, this playlist, real-time strategy game with blueprint series, here I have done a lot of RTS mechanics using blueprints, so feel free to check it out too. So I'll leave everything in all the links in the description. And now let's get back to today's tutorial. Alright, so this is what we have worked on so far for the building placement system. When I press B, you see the building is following my cursor, and it doesn't right now check the validity of the location, and when I click, it places the building there. If I press B again, it does the same. Now the next step is identifying where I can place the building and where I can't place the building. So that's the next thing I want to do. And after that, we will be looking into how to actually integrate the build system. Here, when I select the character, we should see the icons in this area to select which building to place. Okay, now to check the validity, that's the part for today. Let's go to our CLM base building C++ file. Now we already have this check placement validity. All it does here is just do a line trace and figure out the location underneath the cursor, and it doesn't do any more than that. So now let's do something like this. Here, let me select the landscape and let's add a tag. And then remember that. Let's go to our code. Go to the header file. Here I'll add another variable. Just no need to add anything for now. Name. Name. Let's call this not the building placement. CodeLikeMe buildings. That's the required tag. So need this tag on surfaces where we want to place buildings. Right, now here we have this part, and then maybe let's try this. If it is not a block in it, let me cut this and we'll return like this. Or exit if not block in it. And the next condition we need to check is check if the hit result has the required tag. If hit result get not this get actor as actor has tag and pass required tag. So if the actor that we hit here does not contain the required tag, we can add another UE log. Just copy. That's or paste doesn't support placing, and then do a return. If all these conditions are true, we should be able to place buildings. But to track that, let's add the U property will be place. Well, by default it's false. Now here set and place, we can place building and initially I'll make it false. False. Only if we reach this point it would be true. Now when I click, that means when I execute this place building function, here we should do that only if we can place buildings. So here if we building, if this is false, let's add UE log as building. I'll set lifespan of this actor to something like this so that it will be destroyed and return. Okay, now let's test it. Test this far. So here if I click, I should be able to place it. But if I click somewhere like this, it still places it. Why is that? It decided to compile. Well, let's forget that. Compiled. Check. We need to see the output log as well. Okay, press B. Placement validity. So it's not moving anymore if it is not valid. if I click, see, the building is not there. If I click here, building is placed. Can't place here, place here. But it's not moving beyond the last possible location to place. It's kind of nice, but actually I didn't intend to do that, but it seems like it's nice to have that. Okay, right. It's working so far. All right, and the next step is I want to check the area. Like I want to define the extent of the building, and then I need to make sure that area is free to place the building. So for that, let's add a new variable. Property vector built-in extents. I'll add a default value, maybe not this, 500. 500. Oh, fine. The reason to add 500 is if I go to top view and check one of the buildings, here you see the length is, including this whole length, 500. 500. So that's why. Okay. Building extents. Now let's go here. I need to do a box sweep. So for that, define parameters for the thing we need is a vector box extent. Actually, for the sweep, we need to give half extent. So box half extent. Building extent divided by 2 and vector box location. Maybe result location should work, yeah. Actually, we don't need a box location. All we need is start. Hit result location, not minus, should be plus. Box half extent. So not really. We only need to move it upward on the Z direction. So vector box half extent Z. So this should be the trace start, and trace end. I'll just get trace start plus vector just adding one should be enough. Just a little bit of a difference, but no need to trace so longer up. And also we need another thing. If collision parameters and params. If collision query params. Collision params. We can ignore this object, of course, and we can no need to trace complex for now, so let's make it false. And let's have a T array of hit results, 4 out hit results. All the hit results will be going into this array. Now we can perform the box sweep. To pull it, that should be fine. This turn because we need to give a quaternion. Right, now here, if we actually we don't really need to check if b hit is true, because if nothing is blocking, then it should be fine. Nothing, built-in is not blocked by anything. But we need to check if we do have any hits. We need to go through all the hit results. So for this follow, result hit out hits. No, this is not the condition I need. Okay, we need to check the validity, and then we need to check that oh wait, because yeah, required tag should be there because only the landscape will have the required tag, not anything else. So if it does have the required tag, we can place the building, otherwise we can't. And if this is true, actually nothing is wrong, but if this is false, that means the not is true. We can say the area blocked by and put whatever the actor name and not a return. Let's do a break. Well, no, actually we can do a return because we don't need to do any of these things. We can keep the 𝐵_𝐶𝐴NALYZE building false. Alright, so now test. It's not moving. And here, if I keep the mouse here, also it's not moving because there is not enough space. Right? The building is destroyed. Okay, so it's working, but it's not clear because we don't have any indicators. So maybe let's add draw some debug boxes. Yeah, if it is false, before we return, let's add debug box. Draw as the location, let's use start, and box half extended is fine. Let's use this rotation and color red to say that we can't. And if we can, let's do the same thing with color green. So if we can see a green box, that means we can place. If we see a red box, we can't. Okay, test compiled. Right, green box we can place, and red box we can't place. See, here we get a red box. It's broken with something. Okay, right. If you click with the green box, you can place the building. Best. All right, so it's working. Okay, now let's do something small. Some indicator to show actually the placement is invalid in the object itself. So for that, select one of the buildings, open the material. It's instance, of course. Go to the base material. Right here, this is the color. Okay, let's add the overall invalid color. So vector parameter. Actually, this doesn't have to be a parameter. But anyway, let's load this with the actual base color. And here, let's use this. And if I mark this as 1, apply, and every building should become that color. It should become become 0. Yeah. So this should be interchanged. I'll mark this alpha to a parameter in by default it should be 0, but if I make it 1, the building should become red like this. That means we can't place the building there. So I'll make it 0, and then we need to set this. When the building is invalid, in an invalid placement, I need to mark it as invalid. So what's the best place to do that? Maybe here. If let's have a new function for to handle that part. Let's add new view function. And instead of blueprint callable, print. Let's add a function. This should be blueprint implementable event, and I'll call it void toggle build validity to be valid. And we don't need to implement here. Then let's go here, and before we set 𝐵_CodeLikeMe build into false, I'll call toggle build-in validity 𝐵_CodeLikeMe Now we need to implement it here, so let me compile first. The reason that I need to implement that in the blueprint is because material part is more visible in the blueprint, and we might have different materials, we might have different parameter names, so that's why. Cool. Did I compile? Toggle built-in validity. If this is valid, so get the static mesh, set scalar parameter value on materials, select the value based on this. If it is valid, then 1. If it is invalid, 0. That's the way I implemented it, right? Yeah. If it is 1, that means it is invalid. Okay, so it should be reverted. 0 means valid. This should be 0, and this should be 1. This. Alright, now let's see if it works. It is working. I think it would be better if the building moved despite not being able to place it in the location that we are trying to place it. So I no longer need this debug boxes, so let me compile that, comment that out, and select a location here. So the building will keep following. Okay. So maybe something is blocking here. So here we have enough space blocking. Okay, so now you see this is still not following. Wait, did I compile? Still not following. Oh, right. Surface doesn't. It should be here. Location set. If we don't get a hit, obviously we can't change the location because we don't have a location on the hit result. But if we do get a hit, even if it is not supported, we should see that. See? Can't place, can't place, can't place, can't place, can't place, can't place. Okay, great. And that is all I want to do for today. And thanks for watching. As always, updated project files will be available for download in the Patreon page. Link would be in the description below. And let me know if you have any questions in the comments. See you in the next episode. Goodbye.